Hi, welcome to Watershed Walk Day 3. Thanks for watching. So, for this day, we did some quick warm-ups. First, asking what is a watershed. So try to answer these questions on your own. You might want to pause the video because I'll just start answering these. What is a watershed? A watershed is just a land area that drains into a common body of water. What do we call water that does not soak into the ground and runs across the surface? We call that surface runoff. That is water that runs off of the surface, and it could be a grassy surface that's just not allowing the water to drain in very quickly, or it could be a road or something. Number 3, a surface that does not allow any water to absorb is called impermeable. Remember perm, like permit, permeable would allow water to go in. Since it's impermeable, it does not allow water to absorb. Examples of impermeable surfaces would be driveways, roads, roofs, things like that. All right, so what are we going to do today? We're going to review the importance of healthy watersheds and floodplains and estuaries by reading and watching videos and by sharing conclusions in our own words. Why? So that we can see how the features of watersheds, floodplains, and estuaries are all interconnected. So more review. Let's think about the sanitary sewer that we looked at as we were going on our own watershed walk around the Frost campus. The sanitary sewer, the water in the sanitary sewer comes from toilets and sinks and showers, dishwashers, laundry machines, things like that. That water is treated before it goes back into our waterways. So we have water that goes into sinks, into toilets, things like that. It is going to go into a contained system, pipes that are going directly from the building into pipes. The pipes are going directly into the building, and so the water is being contained in the sewer, and then it is moving on to a water treatment plant. It will be treated before it is released back into the waterways. All right, so as the number and size of buildings increases, so that means the more buildings we have and the bigger those are, the amount of surface runoff is also going to increase because we have more surfaces now that are impermeable. We have more roofs, we have more probably pavement for parking lots near these buildings and things. So the amount of surface runoff increases. So here's an example. We are increasing the number of buildings and things that we have, and so it means that we're going to have increased runoff. All right, the main sources of pollution in Fairfax County, if you remember from our walk the other day, we have a lot of sediment, and we also definitely have nitrogen and phosphorus from fertilizer for the most part. So those are probably our two bigger pollutants that we have in Fairfax County, but also we have toxic chemicals that come from cars and vehicles that have leaks, or sometimes we get toxic chemicals from businesses. So just a reminder, when we have soil that has been pulled away from an area because of water or because of rain or because of wind, that is called erosion. Okay, erosion is something that we want to control because if we don't control it, it can lead to bigger problems. If we have this kind of erosion, we have soil and dirt getting into water, and we talked about this the other day. It looks like it's close enough to that fence system that it might actually make that fence buckle. And over here, if our soil is eroded away enough, we might lose our stability against that concrete wall. All right, so how do we prevent sediment from entering our waterways during construction? Think about frost over the past couple of years. We talked about several ways that we can control the erosion. So we can use this black silt fencing. So that allows water to go through, but it doesn't allow soil and rocks to go through. It actually also will keep some litter and things like that from going through. It'll just sort of filter the water a little bit. Also, we can put hay bales in front of storm drains, or this is a silt roll that you'll see in places where there is some construction or renovation happening. This is just designed to allow water to get into the storm drain, but it'll keep some of the silt and some of the other pollutants from getting straight into the water. Okay, we love plants. Plants are always good. And so as we plant trees and grasses and bushes and things like that, those roots are going to help filter any water that is running by, and they're going to help hang on to the soil, kind of hug the soil to keep the soil from washing away as easily. All right, so this is a storm drain. That means that storm water is going into it. Reminder, storm water is not going to be treated before it goes out into the waterways. So think about things that could fall in through those little grates. We could have wrappers or car oil or soap from car washes, fertilizer from lawns, cigarettes and other trash. We can have things get through those little grates. They stop the bigger things. They might stop a soda can or something, but you're still going to have things get in through those grates, and they're just going straight out into the water. All right, today is day 5 for testing for us. So we're going to monitor our ecosystems. And remember, we have now added 9 things. We have added Chlamydomonas, Spirogyra, Daphnia, Alodia, duckweed, pond snails, guppies, fiddler crabs, and black worms. We did get to finally add our black worms. So know those 9 things are in your ecosystems, and you're going to go to this page in your packet. If you are absent on this day, you need to get the data for day 5 from your table mates. Okay, we talked about the room temperature, and we talked about all of the jobs for each of the people in the tables, and spent some time getting the data that we needed. Okay, again, make sure you get the data from your table mates if you were absent. Okay, and you also want to always look through your data. Is anything out of normal range? If it is, you want to make sure to mention that so that we can try to do something to get it back into normal range. And you always want to look and see what changed since the last time. And if something did change, can you make any inferences about why? Think about all of the things that are now in your ecosystems. All right, so moving on. I passed out in class the watershed notes. So if you weren't able to be in class, this is a PDF in Schoology that you can print out. So I'd like for you to try to answer these first 5 questions on your own. So you can pause the video, try to answer these questions on your own, and then come back to the video. All right, so hopefully you were able to answer the first 5 questions pretty easily. So what is the area of land that all drains to the common body of water? It's called a watershed. So we have water that is going to precipitate, and from the highest points in our watershed, it's going to make its way down to the big body of water. Sometimes it's going to just run off the surfaces of these hills and mountains. Sometimes it's going to go directly into these small streams and creeks, which are called tributaries, as they contribute water into the bigger streams and creeks and rivers. Okay, and we also remember that the highest elevation points, the very highest points on our watershed, are defined by this ridge line here, so that when precipitation falls, it's either going to come this direction toward us in this picture, or it's going to go back behind that hill to another watershed. All right, number 2, what surfaces allow water to absorb or soak in so that there will be less surface runoff? That word is permeable. They permit, that's where perm is coming from. They permit the water to soak in or absorb. So some examples would be grass, the forest floor, our athletic fields, things like that allow the water to go and drain into it. Those are called permeable surfaces. And then on the other hand, we have surfaces that do not allow water to soak in. Those are called impermeable. impermeable surfaces. So examples would be roads and driveways and roofs, patios, anything that doesn't allow water to be absorbed. Okay, remember that if we have any storm water, once the water hits the ground and is running along the ground, any surface runoff is water that flows through a watershed, and it picks up contaminants along the way before it gets to the stormwater drain. Okay, surface runoff is water that is not absorbing into the ground. It is just flowing through the watershed and picking up contaminants and debris. All right, if we ever notice that the Earth's surface is being worn away by water or wind, we know that that is caused by erosion. So in Schoology today, you're going to find a link that will help you learn more about estuaries and floodplains. Please go to that link, and there are two different videos in there, one about estuaries, one about floodplains, and there are some other things to click around on and read about so that you can learn more about these features. Okay, you'll use this information to complete the remaining questions in your watershed notes. So you can pause the video while you are doing that and come back and double check your answers. All right, so number 6, a blank is where freshwater and saltwater meet. For example, the Chesapeake Bay. That's going to be an estuary. An estuary is the area of water where we have some fresh water from rivers meeting salt water from the oceans, because of course we have tides and waves, and so there's some mixing. It's partly salty, it's partly fresh. And the term brackish is the term that we use for the amount of salt in that water. You care about the word estuary here, though. An estuary is where freshwater and saltwater meet. So this is an example of our Chesapeake Bay estuary. This dark spot all along here is being fed fresh water from all of these rivers and other tributaries. It's being fed fresh water, but we also have an opening directly out to the Atlantic Ocean, and the Atlantic Ocean is salty. So as that water is mingling, we end up with some partially salty water. This is an estuary. It is partly salty, partly fresh. It is called brackish. And so thinking about watersheds, we know that watersheds are separated by areas of higher elevation, so higher up. So mountain ridges, mountain tops are going to help us define our watersheds, because as I have water fall on these ridge lines, water is either going to go back behind this picture into another watershed, or it's going to come toward us into this bottom watershed that you're looking at in this image. Areas of higher elevation are called ridge lines, and they help define the watersheds. Okay, so you know most of these words. This ridge line is the high up ridges that are helping to define our watershed. Precipitation is mostly going to be rain, snow, sleet. Tributaries are littler streams and creeks that add water into bigger streams and creeks and rivers. So these little things are tributaries. They are contributing water to bigger bodies of water. On the outside edges of any waterway, like a river or a creek, you'll have flat land areas that are called floodplains, and they are naturally occurring, or they can actually be man-made or man-orchestrated, so that there are ways to deal with excess water on occasion. All right, and then of course we have our estuary. If this is fresh water from the river coming in, if this is an estuary, it means that there must be salt water down here at an ocean or something. All right, so small streams that are leading into bigger streams, they are called tributaries. Okay, and in this image, we had something labeled already called headwaters. You don't actually have to know the word headwaters, but I did want to say that headwater streams are just small streams or wetlands at the very highest end of a watershed. Some of them are even so small that they don't even show up on maps. So this is high up in elevation. And so just so you know, these beginning water systems, that are leading into the bigger rivers and then ultimately into our watershed body of water, we can call them headwaters. That's not a vocabulary term for you to focus on. Right, the flat, wide land that's located along rivers and streams is called a floodplain. So this is an example of a floodplain. We have floodplains over here. So sometimes floodplains are good to have because if there's a really heavy storm or some sort of a hurricane or something, we might have water exceed the capacity of our river here and it comes up over the edge. So on those floodplains, they may be wet and messy for a number of days, but eventually that water is going to soak into the ground or it's going to run off back into the river. All right, so this picture is not the best picture ever, but we're going to use the list of words that are actually on your notes to try to define each of the sections of this picture. So realize that this is some sort of a river water area. This is a bigger water area right here. And we're just going to talk about all the terms. All right, so if I look up here and imagine these are the highest points along the ridges and tops of the mountains, that's going to be a ridge line that helps to define my watershed. This arrow is pointing to littler, smaller streams and creeks that are leading into bigger rivers, so that's a tributary. My river system is going to be the little tributaries and the bigger rivers all together. That's the system of river water. So this river system is trying to show all of the types of water that I have going on in this particular watershed. All right, so the entire picture shown by this bracket, this entire picture is a picture of a watershed. When there is precipitation right along the sides of the mountains, if it hits the side of the mountain and keeps running downhill, that's going to be called surface runoff. So it's surface runoff. It might actually land directly in one of these streams or creeks, but if it hits any surface before it goes into a stream or a creek, it's called surface runoff. Finally, down here next to my rivers or bodies of water, I'm going to have a floodplain. All right. So thinking about watersheds, what we know about watersheds. In Frost Middle School, we are located inside this little orange sub-watershed. So watersheds are named for whatever body of water all of the water is draining into. So if I were to spill my coffee outside of the building of Frost and it goes into a storm drain, it's going to drain into the Accotink Creek watershed. This is Accotink Creek watershed. So it's going to go out of my coffee cup and onto the ground and into a storm drain, and it's going to drain into this Accotink Creek watershed. Okay, the Accotink Creek then drains into a slightly bigger watershed called the Potomac River watershed. Finally, either one of these is going to make its way to the Chesapeake Bay watershed. Remember, that's all of this area that feeds into the Chesapeake Bay. If there's water landing on any of this land area, it's going to feed into the Chesapeake Bay. All right, so here's a reminder. You've seen this picture before of different models. We use models as scientists to make sure that we understand. They represent a bigger concept, but it's easier for us to deal with because it's smaller. So our models that we are working on are model ecosystems, those fish tanks that we have. So just so you know, there are scientists who are paid to do the same work that you are doing when you are monitoring the water quality of your ecosystem. And they grade the Chesapeake Bay watershed system. They grade us as citizens on how well we are maintaining our Chesapeake Bay system. Or they might be grading environmentalists who are trying to make sure that the Chesapeake Bay is getting healthier. So look, it's 2022. We've got some data from 2022. We got a D+ for the Chesapeake Bay. Okay, we also had a D plus back in 2020. So let's look at some of the things that the scientists have used in order to grade us on our watershed. So first we got a D and an F over here. Remember, nitrogen and phosphorus come mostly from fertilizer. And so we have nitrogen, we got an F, really low, 17. Maybe think of that as like 17% on a test or something. That's pretty bad. We also have a D for the amount of phosphorus that we have. Remember, when you are testing your own ecosystems for nitrates, you're using that little vial, you're putting in 5 milliliters of water, and you're adding 5 drops of the nitrite solution. You're waiting 5 minutes, and then you're comparing the color of your nitrite solution to a table that lists different colors. That is also the type of thing that scientists are doing in order to measure the water quality of the Chesapeake Bay. So nitrites, that's just a different form of nitrogen. So those scientists might be using very similar testing equipment to what we use. Dissolved oxygen, we measure dissolved oxygen, so do they. Our dissolved oxygen in the bay, we have a C. That's not super bad, but we always know that the better the dissolved oxygen is, the more plants can perform photosynthesis, and generally the healthier the water. They have an F on water clarity, and so it's gone down. It's even worse than it was before. And we have a D for toxics, meaning that toxic chemicals that have leaked out of our vehicles or that have been released from different businesses are getting into the water. So please remember, you as a scientist in the classroom have been doing many of these water quality tests, and they are similar to what real scientists, real paid scientists are doing out in the world. All right, so in addition to testing the actual water quality, the scientists who are giving us this report card are also testing the habitats that are right along the water. So when we think about forest buffers, we actually have a B. We're doing pretty well with that. It's a buffer area that's trying to put plants and things in between our water runoff and the actual Chesapeake Bay, because we know that plants, including their roots, are going to help clean up the water and protect the watershed, Chesapeake Bay. Okay, we also have some wetlands where you might find a crane or an egret or something like that, a heron. And so the wetlands, we have a grade of C. For our underwater grasses, we have a grade of D minus. And for our resource lands, maybe like farms and things, we have a D plus. So with these scores, scientists might try to propose things that they think are being harmful to the Chesapeake Bay. And so they might suggest to government workers or to farmers or business owners ways that they can change their practices to try to improve the quality of the water that is draining directly into the Chesapeake Bay. All right, so let's think about why the bay is so easily polluted. It's hard to keep it clean. It is easily polluted. So think about this. You have dirty feet. If you were to walk through this little kiddie pool, think about how the kiddie pool is going to be after you're done walking through it. Or if you were to walk through an Olympic-sized pool, what are the effects? What's the difference here? Well, if you walk in that small kiddie pool, it is smaller, it is shallower, and it does not have nearly the amount of water. It has way less water than this Olympic pool has. So the same amount of dirt in here is going to make a really big difference compared to this amount of dirt in the big pool. It'll still be the same amount of dirt, but it's going to be much more obvious in that kiddie pool. Well, that's very similar to what's happening in the Chesapeake Bay. So you probably learned this type of thing in 5th grade. Just want to watch when we're at the beach, up here at the beach, and we're looking in the ocean. We know in the beginning the water is pretty shallow, but pretty quickly it's hundreds of feet deep. Okay, there are places in the ocean where it's 13,000 feet deep, and then way down we can even get to 36,000 feet deep. So this is a lot of water when you think about how deep that is. The Chesapeake Bay, though, this is the water right here. So we are actually probably even to the left of this shallow water. So it is on average 21 feet deep. That is not very deep. So when we think about those dirty feet cleaning off in the kiddie pool compared to the dirty feet cleaning off in the Olympic-sized pool, our Chesapeake Bay, it's more like that kiddie pool because it's a lot of land that is feeding into just a small amount of water. So the Chesapeake Bay watershed empties into the small little container of water. Whereas other watersheds in the world, when they are emptying their water into a larger body of water, it's more like they're going into the Olympic pools. So let me show you what I mean. Okay, when I look at the watershed, that's the stuff in green, and I think about the land to water ratio, that's a lot of land compared to the amount of water in our whole watershed system, right? So let's look at some numbers, right? If green is the land and blue is the water, it's a whole lot more land than there is water. All right, over the whole world, we have the Hudson Bay right here. Here's our Chesapeake Bay right here. We have some other things that we're going to look at over here in Europe. We're going to look at Kattegat and the Belt Sea, and we're going to look at the little bit into the Bothnian Bay. So just realize that we do have watersheds along these lots of areas. But we're going to focus just on a couple, on the Chesapeake Bay and on a couple over here. So look and see. If I'm thinking about the ratio of land area to water, for the Baltic Sea, it's 79 to 1. For the Kattegat, it's 206 to 1. So more land for the same amount of water. Belt Sea, it's kind of in between those two amounts of land. The Hudson Bay, it's in great shape. It's only, that's up in Canada, right? Hudson Bay. It's only 25 to 1. So there's a lot of water, really, right? It's not a huge amount of land for the amount of water. The Chesapeake Bay, however, so much land to water. Check out this ratio. 2,743 to 1. So much land leading into a small amount of water. So this is the reason it's like the kiddie pool. And any small amounts of contaminants and pollution are going to have a big impact on our water quality. This is the same information that I just gave you in a different kind of a graph. So you can see it's the same numbers. Hudson Bay is 25 to 1, right? The Belt Sea is still 95 to 1. Kattegat is 206. And here we have the Chesapeake Bay. It is 2,743 kilometers squared of land area per 1 kilometer cubed of water volume. So it's just the same information in a different graph because sometimes we understand things differently depending on how they are presented to us. All right, so just a quick reminder of where some of these locations are. All right, so let's have a quick review, and then you want to make sure that you are completing other information in your Schoology. You have slides about floodplains and estuaries, and you also have an exit ticket for Watershed Walk Day 3. Double check and make sure that you've done the exit ticket for Watershed Walk Day 2 and also the Schoology assignment that was a reflection from our Watershed Walk. So you'll want your Watershed Walk notes in order to do that reflection. All right, so just as a quick reminder, before you do your exit ticket, a body of water where fresh water and salt water meet is called an estuary. Where is this? What is this arrow pointing to? It's pointing to the green grassy areas. This is the floodplain. So we have two bodies of water. There's one kind of darker river, brownish river here, and there's a bigger river here. So this floodplain is where water will overflow if it overflows out of that river. Okay, that's a floodplain. The land that the water flows through on its way to a bigger body of water is going to be called the watershed. That is the land area through which water flows on its way to one single big body of water. So it's called the watershed. All right, if I think about all of the water that's going to be coming down hills and leading into this creek or river, I know that these areas must be higher up since the water is flowing down them. So the high up lines that help define our watershed, they're called ridge lines. They are natural geographical features. All right, and what am I pointing to? Here and here and here. Those are all smaller creeks that are running into bigger rivers. So those are going to be tributaries because they contribute water to the bigger rivers. The water that flows through a watershed, remember it is flowing through a watershed and picking up contaminants along the way. It is running along the surface. It's called surface runoff. All right, and a reminder, you want to finish your Watershed Walk Day 3 exit ticket. You want to use the slides link so that you can learn more about estuaries and floodplains. And then double check. If you did not finish this assignment last week, this assignment was posted in Schoology, you want to make sure to get this done. The assignment in Schoology called Reflections from Watershed Walk Day 2 was to pick 4 key words from the Watershed Walk that highlight what you learned on that Watershed Walk. And then using those 4 words, write a brief summary of what you learned so that you could explain to someone who wasn't there exactly what we might have done on our Watershed Walk. What did we learn? All right, again, I thank you for watching, and don't forget, if you are taking this class with me, you have a test on the next class. So thanks again.